Hi, welcome to another video on my Raspberry Pi 1 and electronics using pulses modulation on an LED and a pulses modulation motor. Last time I changed my circuit to the situation you are watching it now, which means that a pulses modulation coming from here to this little transistor circuit, and this motor didn't run on that, so I rerouted it to the op amp. Pulses modulation fed to the power here, and that didn't work either. When I use it on full 5 volts, then it runs, but as you can imagine, that is no use of pulses modulation. I also checked whether pulses modulation as I use it now is affecting this LED, and the answer is no. So the question is now how to proceed. I did use pulses modulation soft, and that worked on the LED quite well, but it didn't do anything on the motor. Now I have changed to pulses modulation hard using direct memory access, and the result on the motor was nil. Just nothing. And according to the information, you can use a stepper motor, you can use a DC motor, but what is a pulses modulation when a motor when it doesn't respond to pulses modulation? And that is the big question for now. The problem is also that I have measured the voltage over this part of the circuit, and that was very low, extremely low. Too low to, I think, even drive that LED, but certainly too low to drive this motor. Now the another problem is that from here to here are the power 5 volts. But the problem is also that either of these pins coming from the RPI, from the GPIO of the Raspberry Pi, let me say it correctly, can be set high and low, and high and low only. Low is 0 volts, high is 3.3 volts, so not 5. Will this be enough to drive a motor? Very likely the answer is no. Since the motor needs at least 5 volts, because then it very certainly starts running. But then how can it be that on the power controller from Fischertechnik it runs on 9 volts and power and pulses modulation? Well, 5 volts is no 9 volts. So I think there is a problem. Now when looking at my software, I find a very different point, that I view things completely mixed up. Is that of influence of this situation in hardware, only one way to find out. Leave this as is and concentrate and tidy up the software. So that is what I'm going to do next. Going through the code again. This is preparation for the GPIO, general purpose input output. This is the line that imports pulse width modulation hardware from the RPIO module. This line says to set the mode for the GPIO to board mode, in contradiction to BCM mode. BCM is GPIO and a number like GPIO 17. Board treats everything like pin 11. So here I set up pin 7 to out, pin 11 to out. If I would have set BCM here, it would have this line would have read GPIO 17, comma GPIO.out. Then here I set up PWM and here I initialize it. Now the point is that if I use this one, as I did last time, I am not using this PWM. I am using GPIO. So one careful thought might be using a GPIO, not RPIO. So effectively I have to scratch this one out. Same goes for this one. Now here this I don't care about, but here once again the same thing. And then suddenly here I'm using PWM again. So this whole stuff can go. No, except maybe for this one, for this line, but I've already shown in the previous two videos that this is not working at all. So when I say uncomment, it's fine. I can uncomment this one as well. GPIO cleanup makes no has no use here, because that works only for this one, for this part, as I'm using GPIO here. Then of course the big question is, what does work? Because now I am using the actual hard pulse width modulation with a maximum width of 1999. The only thing that may be useful is setting here pin 11 as output. And one reminder, as I said in introduction, setting this to out and making it high means that there is a voltage over it of maximum 3.3 volts, not 5 volts. So what I can do is measure it and then see what happens. That's the only thing I can show, and then be sure that at least that part is alright. What I can also do is figure out which frequency is working here, but apart from that it just should work. Although a frequency of 30 Hz is normal, is working, and up to 62 kilohertz is working, as that has been proven in the past. So how to go on? Not really sure, but we'll find out, I hope. So with that reasoning, first thing to do is to actually run the adjusted software. Which goes wrong. Let me see what it does. It says channel 3. Yeah, I have to change from channel 3 to channel 0. Now it actually goes right. And then this is the pulse width modulation. So first I have to check here what the voltage is. And the pulse width is going up. It's around 18 now, 20, and right now it says hardly any voltage. 1.6. So now another point is here that I am leading the signal here through these resistors. So anything that is here is reduced by these resistors. So what I best do is make sure that I cancel out these resistors, at least this one for now. Put this wire right here. And then see if this works in any way. And I have to admit, I don't see any sign of glimmering. Well, the width is now at 65. And let me measure here. 1.5 volts. So conclusion is that from the 3.3 volts it is the pulse width modulation voltage is not even that. It is 1.5 volts maximum, which is actually extremely low and maybe not even enough to let this LED burn, let alone to have a motor run. Now, to make sure that this motor actually does something, now I have interrupted I've taken away this wire and you see that this LED starts burning. Now you see also something remarkable. I just hold it to the output pin of the op amp. And only moving slightly, and you see that you see what's happening. This is rather curious. I can't really explain it. But then connecting it to the plus makes the motor run. And this is something different. Can't explain yet. But this voltage is way too low for the motor. That's one thing that is sure. So what next? Now the question is, of course, with this effect on this LED, what voltages are on there? So right now this is 0.8. When I remove this, it's 2.5 volts. That's a very clear difference. So what takes the power away? Probably this motor. Here is 0.7 and let's try to get a voltage here. Zero as expected because it's mass. But this 0.7, 0.8.5 is of course way too low. So now if I turn up this pot meter, what will happen then? The motors will start running. This is now 3.7. And this is 3. Well, it's almost 4.0. But as shown in the previous videos, this has nothing to do with pulse width modulation control. This is voltage control. And with that, I think, let me, for another conclusion, measure here on this LED 1.4. Yeah, it's half of the ordinary voltage. So with that, I think without having a proper voltage gain from an op amp, this little experiment, lengthy experiment on with both software and hardware pulse width modulation on this motor and on this LED is no use, which is too bad, by the way. So I don't have any other motor than a pulse modulation motor. Nominal it runs on 9 volts. I can't get that. Although with 5 volts on an Arduino I can regulate the speed with pulse width modulation. And if I look at this, alright, this is 3.8, so if I turn it up, well, it can't get up any further. Oops. This is 4. This is more than, this is about 4. The pulse width is again back to 66, or is now 68 anyway. That said, if I just, what if I change that? Change the software to what I think it should be. Let me try that. Yeah, and that is a problem when you just start going. Here it caps up, but here it has a fixed width, so I changed this a little bit, but I don't expect it to change to improve. Now the width is 1 and no longer steady 1999, and I am measuring the voltage, which is of course still just above 4 volts on the motor. Then I should check the frequency, so I set the frequency on a upper limit of 20 kilohertz, and I measure on the motor. And it says 7 kilohertz. Then I measure on the LED, which also says 7 kilohertz. Now, more interesting maybe to do it like this. Let's just comment this out and say, okay, I want this to 500, a quarter of maximum, and then of course comment this in, which also implies, since there is no while anymore, yeah, this is in a while, this while, the continuous while, so this can stay in this place. So let's see what effect this has. Measuring again, 7.6, 7.7, and measuring on the LED, exactly the same. No surprise there. So changing this then to 1000, which is actually halfway. Then it says slightly higher, 8 kilohertz. And same goes for the measuring the LED, it says 7.4 kilohertz. The motor says now around 8. Slightly higher, but not 10 anymore. A bit, sometimes 8. So, alright, then let's go down to 250. 250. What's the change? Frequency. Frequency at the LED. Around 7. At the motor. 7.7. So it is barely noticeable that about any change. While there should definitely be change. So the big question is, what use is this pulse width modulation variety on the motor? It is intended apparently for just pulse width, for just a servo, and maybe others, but not this type of motor, unfortunately. So let's think how to proceed. As a last attempt right now to get some of it maybe working, is paying attention to this short sentence. As yet only BCM GPIO numbering is supported. And I was talking about that earlier, and this means that this line has effect insofar that it works on the GPIO. So if I remove this, then say, alright, let's copy this one, paste, comment out, BCM, as it says, BCM. Then 11 is here GPIO 17, so this has to be changed into GPIO 17. Yes. Will it work? I have no clue. All I can do is try it. So let's see if it works. GPIO 17 is not defined. So how does it work here? Just a 17. Alright, let's call it 17 then. Let's just 17. I'm fine. Alright. And let's probe frequency. Changing from 9, 10 to 13 at the LED. At the motor it says now 10 kilohertz. With the LED it was also in kilohertz. Then it is interesting to see what the voltage is. I expect no change at all, but let's just see what happens. Still 1.5 volt, no change there. At the motor 3.9, almost 4 volts, which is not the same as 5 volts. So, is that a clear conclusion? I don't think so. Let's go back to frequency. One more test. I change this to 1000. Let's see what happens. One final time. At the LED 13 kilohertz, back to 10 kilohertz, and it stays that way. At the motor 10 kilohertz. So, is that a change? In my perspective, no. It would have been a change if the rotational speed of the motor would have changed. No such thing. Is this the end? For now I think it is. Pulse modulation is too nice to not to use, but other than on my Arduino experiments with constant 5 volt output, this one is not going to work, even though this is clearly set via DMR, via direct memory access for the Raspberry Pi. Even though this is the case and I'm setting it up using it, it's not working. Wrong motor? Who knows? I'm not giving up. So for now, thank you for watching. If you like this video and haven't subscribed yet, please do so. If you don't want to subscribe for any reason, I'm also using Twitter. I'm also using Instagram. Quite a few people follow me on Instagram. If you like to donate to keep my blog going, please visit my website for more information. It's listed at the start of this video and under this video. And this is to be continued. Bye bye.